All right, welcome to our lesson on division of polynomials, the last mathematical operation on polynomials that we learned. First, we learned how to add and subtract them, then we learned how to multiply them. Now we're finally going to learn how to divide them. Why do you think we leave division till last? Well, because it's technically a little bit harder. Students tend to struggle with this a little bit. And really the reason why we struggle with it is because we've forgotten how to do long division, right? We've been using our calculators for so long that we have forgotten how to manually divide a big old number by another number, because that's all we're doing with polynomial division. Is we're doing the exact same process we would have done if we took, like 35,473 and divided it by 15 and tried to figure out what the remainder was. That's what we're doing when we're doing polynomial division. If you can remember that old technique from way back when, we're doing the same thing here. Now, we're going to start easy, and we're just going to divide a polynomial by a monomial, which basically just means you're going to take every single term of your polynomial and divide it by that thing, whatever that thing happens to be. And of course, whatever we're dividing by can't be 0. So in this case, we're dividing, by c. This is a big typo. This should be a over c plus b over c. And same thing with subtraction. They screwed it up again. This should be a over c and b over c. Okay, so let's try this one. Each term is going to be over 5a. So it's just going to be 5a cubed over 5a minus 10a squared over 5a plus 20 over 5a, and then it's just a matter of cleaning it up, right? We have the 5's cancel. We got a cubed divided by a. We just get a squared. Again, 10 and 5 cancel. Just give me a negative 2. A squared divided by a leaves me with just an a. Here, the 20 and the 5 cancel, and I just have 4 over a, or you might write it as 4 times a to the negative 1, right? Just depends on which way you want to write it, right? These two things are the same thing. Okay, same thing here. We have this over negative 6y squared z dot, 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 right? They're all going to be divided by that. So 12 divided by negative 6 gives me negative 2. I've got a y squared and a y squared, so those go away. A z cubed and a z, so I'm just left with z squared. Now, negative 15 divided by negative 6. Okay, so the negatives cancel. 15 divided by 6. Well, they're both divisible by 3, so I get 5 halves. So plus 5 halves. And in fact, I think I'm going to have some crap left on the bottom because I've got a y on top and a y squared on the bottom, right? I've got a y over a y squared. So it cancels and I'm left with a y down here. I've got a z squared on top and a z on the bottom, so I'm left with a z on top. The negative 6y squared z. Well, you can see the y squared z's go away, and 6 over negative 6 just leaves me with negative 1. So this should highlight to you that when we do division, it's quite possible that you're going to be left with a term that has variables in the bottom of the term, right? We've got an a under here and a y under here, and that's totally fine, right? It's still a polynomial. We're still good to go. It's just not one of our standard polynomials. Okay, so let's look at long division. So instead of dividing by just a monomial, one thing, we have to divide by a binomial or worse. Now, if we're dividing by something as simple as this x minus 3, then you can use synthetic division. So if anybody's ever learned synthetic division, this is the one and only time where you can use it. I never teach synthetic division because it's a very limited technique that only works when you're dividing by a very specific binomial. You have to be dividing by a binomial, 2 pieces. The first piece has to be x, and the second piece has to be a constant. And that's it. You can't even do it if this is a 2x, right? It has to be 1x plus or minus a number, and that's the only thing that you can use with synthetic division. So it's a very limited, in my opinion, waste of time thing to learn. Instead, just do long division. It works for everything, right? It doesn't matter what you're dividing into what. Long division works, and it really comes back to remembering how to do long division with a big number. So for instance, if we're trying to take 17, let's do, let's do a number that's easier than 17. miserable. Let's go back to 15 into 3, 5, 4, 2, 0, right? And you go, okay, well, to do long division, I figure about what's the first thing 15 can go into. It can't go into 3, but it can go into 35, and it can go into 35 2 times. Then what I do, I take this number and I multiply it by this number. 2 times 15 gives me 30. I put it here. What do? I subtract this from that. I get my leftover, and I repeat the process. It can't go into 5, so I bring the next one down. It can go into 54. How many times can it go into 54? 3 times. 3 times 15 gives me 45. I subtract it, which gives me 9. Can't go into 9, so I bring down my second one. It can go into 92. How many times can go into 92? 6 times. 6 times 15 is 90. Subtract it, leave me with 2. Bring down the 0. It can go into 20 once. 1 times 15 is 15. Subtract it, remainder of 5. So there's my answer with remainder of 5. That's long division. We're going to do the same damn thing, but with variables, right? The only thing you have to remember is that when we're dealing with polynomials, you have to have a placeholder for every power of x. Same thing with numbers, right? This 0 is a placeholder telling us that we don't have any 1s. If it wasn't there, then the number would be 3,542 instead of 35,420. So the 0 is really important as a placeholder. Same thing here. If we didn't have this x, we would put plus 0x and then plus 3. But we have one, so we put it there, and then 3. And now it's just take this and figure out if it can go into the first thing, and if so, how many times. Well, 2x squared divided by x just gives me 2x. 2x times x gives me 2x squared. 2x times negative 3 gives me negative 6x. And now I need to subtract. Now, subtracting negatives can be tricky, so we often say instead of subtracting, change signs, right? Multiply by a negative 1, and then add. 2x plus the negative 2x, this goes away. This better always go away or you've screwed something up. Negative x plus 6x gives us 5x. And then bring down the next piece and do it all over again. X into 5x goes plus 5 times. Now take this and multiply it. 5 times x gives me 5x. 5 times negative 3 gives me negative 15. Change signs and add. 3 plus 15 gives me 18, and there's my remainder of 18. Now, when we do this kind of division, rather than just listing the remainder as 18, we would normally say the answer is 2x plus 5 plus 18 over x minus 3. Because you remember, if we did this division, our remainder of 5 would be 5 over 15, right? That's our remainder, plus 5/15, which we would reduce to 1/3, of course. So the answer when we do this division is 2,361 1/3. Same thing here, 2x plus 5 and 18 over x, right? Whatever our remainder is over our divisor. So that's the nice parallel between numbers and letters. All right, let's look at another one. Now, like I said, we could not do synthetic division with this one. So we would have to do it by long division, which is why it's better to learn this one. Okay, 3w cubed plus 26w squared plus 0w, right? We got to put in every power, and then minus 3. So we have that placeholder. You know, again, it's like the number 23051. This is a placeholder telling you you don't have any hundreds, right? 23,051, no hundreds. That's what this is doing. So 3w into the first thing obviously goes w squared. Multiply it through 3w cubed, and then times that is minus w squared. I'm going to change signs and add. Leaves me with 27 w squared. So nice of them to make these work out with nice pretty whole numbers, because 3w into 27w goes plus 9w, right? 9 times 3 is 27, w squared, right? So that's 27w squared. Haven't messed that up. 9w times minus 1 gives me negative 9w. Bring my 0w down here. Change signs and add. leaves me with just 9w minus my 3. 9w divided by 3w, that gives me plus 3. 3 times 3 is 9, right, w? I didn't screw that up. 3 times negative 1, negative 3. And holy crap, look at that. They match, no remainder. Yee-hoo! I've got a perfect answer with no remainder. Now, obviously, this is pretty rare, but a lot of math books will set this up so that you do get ones with no remainders. Let's try another one, right? If they give us this, doesn't matter. Still same thing. 1 plus y squared is going into y to the 4th plus 0y cubed plus 0y squared plus 2y minus 5. Now, the only thing you really want to do is instead of doing 1 plus y squared, you should always list your divisor, this thing on the outside, in standard form as well. Remember, standard form of polynomials is always highest degree first down to lowest degree. And so now, again, first thing, well, that goes in there, y squared. Y squared times everything gives me y to the 4th. Plus y squared, I'm going to put it over here, plus y squared, right? You want to stack up the like terms. All right, subtract, right? You can change signs and add, but this goes away, and then 0 minus this, so I have minus y squared. Plus 2y. I'm not going to bring down a 0y cubed because I don't have any of those, so I'm not going to try and divide into that, right? So now I'm going to go y squared into negative y squared, which is just negative 1. Which gives me negative y squared minus 1, which doesn't work here. I've got to put it over here, bring this one down, change signs and add. These go away. 2y is still there. Negative 5 plus 1 is negative 4. And y squared cannot go into 2y, so we're done. Our answer would be, right, would be y squared minus 1 plus 2y minus 4 all over y squared plus 1. And that's how we would list that, because you can't divide any further because the degree of the polynomial on the bottom is bigger than the degree of the polynomial on top, so you can't pull any more, y squared plus 1s out of it. All right, let's look at our last few examples where we now have to, well, we just need to figure out if long division is necessary. Obviously, long division is not necessary here because we're just dividing by a monomial. Long division is not necessary here because, again, we're dividing by a monomial. Remember, you just take each term and divide it by this piece. Long division would be necessary here, and it would be necessary here. And it'd be a bit of a pain in the butt because we haven't done something like that with the multiple pieces. But it's still the same process. I'm not going to do this one because we've done things like this a million times. You guys can do this on your own. But this one, same process, right? P squared minus 2p plus 1 is going to go into 2p to the 5th minus 8p to the 4th plus 0p cubed plus 0p squared plus 4p minus 16, right? We still have to put all those placeholders in there. Okay, so now let's see what happens. All right, p squared into 2p to the 5th. Well, we need a 2 and p cubed, right? Because p cubed times p squared gives us p to the 5th. And then just repeat it. 2p cubed times this one gives me negative 4p to the 4th, right? 3 and 1. And then plus 2p cubed, because 2p cubed times 1. All right, change signs and add. So negative 8 plus 4 gives me negative 4p to the 4th. Add these two together, 0 plus the negative, so it's really just negative 2p cubed. And then we have the 0p to the squared. And now we repeat the process. So negative 4p to the 4th, p squared into that. We need the negative 4, and we need a p squared, because 2 times 2. So this gives me negative 4p to the 4th. And then negative 4p squared times negative 2p gives me positive 8p cubed, right? Because there's 2 of them here and 1 more of them there. It gives me 3 of them. And then finally, the last one is just negative 4p squared times 1. So that's just negative 4p squared. We're running out of room here. All right, these cancel, obviously. Change signs and add, right, becomes positive, becomes negative, becomes positive. So we add the two negatives and we get negative 10p cubed. I'm going to, I guess I'll put it up here. I don't know. I'll run out of room. And then plus 4p squared. And then plus 4p. All right, so negative 10p cubed divided by p, right? So we need a negative 10 and then another p. So that's going to give me negative 10p cubed. Negative 10p times this gives me positive 20p squared. And then negative 10 times that gives me negative 10p. Change signs and add. So I've got a positive 4 minus 20. So that gives me a negative 16p squared. And then I've got the plus 4p here from up there. And then the 10p here, because remember it was negative, but we changed signs so we can add. So we get plus 14p, and then we bring down the last piece is 16. And we're basically now repeating the process with this. This should have been down underneath here, but I ran out of room because I'm a moron. All right, so p squared into here, negative 16. Multiply that through, gives you negative 16p squared, gives you plus 32p, and it gives you negative 16, right? Change signs and add. Those go away. Negative 14 plus, I'm sorry, positive 14 plus a negative 32 gives you negative, what is that? 18p, and then these go away. So there's my remainder, negative 18p. So it'd be all this stuff minus 18p over this thing still, p squared minus 2p plus 1. Okay, so that one's tricky, but you can see that the process is the same if we have a trinomial, 3 pieces going into a polynomial, or a binomial. We still do the same process every time. And that's all I've got for you.